In this video, we're going to be talking about the wave equation. The wave equation is the equation that we use to describe what a wave looks like in a particular place or at a particular time. Now notice this wave equation is an equation of two variables, position and time. You can see from this drawing that the wave looks different at different places. That's why position is one of the arguments. Now I can't draw this, but a real wave is also moving, perhaps from left to right or from right to left. That's why you also have to plug in time. Now there are 5 main parameters that we use to describe what a wave looks like. They are amplitude, period, wavelength, phase constant, and offset. Each of these quantities changes slightly the way the wave looks and behaves. The first is amplitude. Amplitude just describes how big the wave is. In this example, we can see that as I change the amplitude, the height of the wave changes. In a sound wave, for example, the amplitude is interpreted by the human ear as how loud the sound is. A higher amplitude wave is a louder sound. Our next quantity is period. The period of a wave describes how long it takes for the wave to return to its original starting point. If we start with a peak of the wave at the center line, the period is the amount of time it takes for the next peak to arrive at the center. Increasing the period causes the wave to move more slowly, while decreasing it causes the wave to move more quickly. Next we have wavelength. Wavelength, as the name implies, describes how long the wave is. In other words, the wavelength is the amount of space between two identical parts of the wave. In this case, from this crest to this crest. Increasing the wavelength stretches the wave out. Decreasing the wavelength squishes it together. Next we have the phase constant. The phase constant just describes the initial position of the wave. If you increase the phase constant, the wave moves to the left, while decreasing the phase constant moves the wave to the right. Notice that when the wave is actually moving, we can't necessarily tell what the phase constant is. The wave still looks the same. The phase constant doesn't affect the shape of the wave or how fast it moves. It only affects where the wave starts. The final piece of the wave equation is called the offset. Notice in this example that the highest point on the waves and the lowest point on the waves are the same distance from the x-axis. If we increase the offset, we push the wave up above the axis. And if we decrease the offset, the wave moves down. The other thing that we have to keep in mind is the direction that the wave is traveling. The direction of travel is determined by whether we plug in a plus or a minus sign at this part of the equation. If we plug in a plus, then as time passes, the wave will move to the left. If we plug in a minus, then as time passes, the wave will move to the right. By combining different values for all these parameters, we can make all sorts of interesting kinds of waves representing all sorts of interesting kinds of scenarios. Once we've determined all these parameters, we can always plug in a position and a time to figure out what the wave looks like at that place at that time. Often, we will show what a wave looks like in space, but allow time to change to show the wave traveling. We'll be using this equation a lot in this quarter, so it's good to get familiar with it. You should have a link to a simulation that allows you to move these parameters around and see how it affects the wave. Feel free to play with that as much as you want to help you understand how each of these parameters affects how a wave behaves.